Alright guys, this is Miss Garner, and today this is the mini lesson on rational and irrational numbers. First, we're going to go over what a rational number is. Its definition is any number that can be written as a ratio. Remember, a ratio is just a fraction. You'll have an integer a and an integer b. These can be anything except for 0. A can be 0, but b, you cannot have a 0 in your denominator. So any number that can be written as a ratio or fraction is a rational number. For example, you have the whole number 6. This can be written as 6 over 1, which is a ratio. If you have the decimal 0.5, this can be written as a ratio 1/2 or 1 over 2. Two types of rational numbers are terminating decimals. This means a decimal that has a finite number of digits. Your example of a terminating decimal is right here. Your decimal stops at the 5, 0.5. It doesn't go on forever, it comes to an end. Terminating, remember, terminate means to stop or to end, so a terminating decimal comes to an end. And your second example is a repeating decimal. This is a decimal that has one or more digits that repeat indefinitely. So in this case, we have 0.34343434, and then these dots at the end means it goes on forever. This is a rational number even though it goes on forever because it repeats. It has this pattern, so we would be able to know what the 1000th digit of this number is because of that pattern. You will also see something that looks like this. If there's a bar over a digit, that means that it repeats. So 0.5 with the bar over it is the same thing as saying 0.5555 goes on forever. So terminating decimals and repeating decimals are both rational numbers, as well as anything like a whole number, negative numbers, integers. Those are all rational numbers. The large majority of numbers that we work with in 8th grade math will be rational numbers. Irrational numbers, you can think of as just being the opposite. They're any number that cannot be written as a ratio, which is just an integer a over an integer b. B can't be 0. So the types you will most likely see are the square roots of numbers that are not perfect squares, and then numbers that have pi in them. So if we think about a square root, that means we're thinking of what number times itself can give you the number under the root. Well, if it's a perfect square, that answer is going to be an integer. It's going to be a whole number. But if it's not a perfect square, the answer results in a non-terminating, non-repeating decimal. So it's a decimal that goes on forever and doesn't repeat. So over here, I'm going to write out our perfect squares. We have 1 squared, which equals 1, 2 squared, which equals 4, 3 squared, which equals 9, 4 squared, which equals 16, 5 squared, which equals 25, 6 squared, which equals 36, 7 squared equals 49, 8 squared equals 64, 9 squared equals 81, and 10 squared equals 100. If it's not one of these numbers, these are your perfect squares. If one of those numbers is not under your square root, then it's not a perfect square and it's going to be irrational. So the square root of 15, that's going to be somewhere between these two numbers. It's between 9 and 16, so it's somewhere between 3 and 4. It's going to be 3 point something. But this is going to be an irrational number because that's not a perfect square. Same thing with the square root of 8. You'll see that 8 is going to be somewhere between here. It's going to be between 4 and 9, probably closer to the 9, right? So this isn't an integer. It's going to be an irrational number. It's a decimal that will go on forever, not repeating. So that's also irrational because 8 is not a perfect square. The other type that you'll see a lot is when you have pi involved. Pi is probably the most famous irrational number, and most of you guys will know by now. Here's your symbol for pi, and it's equal to 3.14159, and it goes on forever. These digits never stop. They never repeat. So if you see any number that has a pi in it, like 2 pi, that's 2 times pi, that's also got to be irrational because that pi makes the whole thing irrational. It's going to be the same thing with pi over 3. This pi is going to make this whole number irrational, even though it's set up as a fraction. Because pi is not an integer, this is not a normal ratio, so because that pi is there, this is also going to be an irrational number. And now you know more.